Alright, so the second half of our unit involves fractions. So in this video we're going to cover just some fraction basics. So this video will actually be 2 pages in our notes. So we're going to convert between improper fractions and mixed numbers. That's the first 2 boxes. We'll look at equivalent fractions, and then we'll look at simplifying and reducing fractions, and then lastly we will look at comparing fractions with our less than, greater than, and equal to symbols. Okay, so make sure you've got your blue note packet out and you're on the fraction, start at the fractions here. This should be the first page you're on. So changing an improper fraction to a mixed number. So an improper fraction is where our numerator, that top number, is bigger than our denominator, the bottom number. So this is improper and we want to change it to a mixed number. So in order to do this, we need to take our denominator and see how many times we can fit it into our numerator. So how close can I get, how many times can I get 6 into 25? As close as I can. So if I'm kind of thinking, I know 6 times 4 is 24, so I can't get any closer to 25 without going over. So that makes our whole number. So that means we're actually taking 24 out of that numerator and making it our whole number. So that means we have 1 left over, so that's our new numerator, and then our denominator stays the same. Okay, so these are still equivalent. They're equal. I haven't changed the value of anything. I've just changed the form that it's written in. So this one is an improper form. This one is mixed number, which is just more proper and further simplified. So 4 and 1/6. So let's look at one more example, and I'll have you try some on your own. So 8 can go into 14 only once. Okay, it can't go in there twice because 18 times 2 is 16, and I only have 14 available. So then we're going to take 8 away, because 8 times 1 is only 8, and we are left with 6 left. So 6 out of 8 still. That denominator stays the same. And we're going to take this one step further. We'll cover this again in another box. But to simplify here, I'm kind of thinking, what can I reduce both of these by dividing? And the first one that kind of comes to my mind is 2. So this will simplify to 1 3/4 for our final answer there. So again, these are all equal to each other. It's just this is the most simplified proper form. So right now I would like you to pause and try these 4 and then play to see how you did. Alright, so now that you're done, 9 can go into 33 whole times. Okay, and that's 27, so we're taking 27 away. 9 times 3 is 27, which leaves us with 3 left over out of our 9, and then we can reduce that one more time. This time we're dividing by 3. Okay, so I'm going to jump down here to this one. 8 can go into 67 whole times. So 8 times 7 is 56, so we're taking that 56 away. Which leaves us with 4 out of 8. Again, I can just kind of simplify this one step further to get 1/2 there. And then make sure you bring in your whole number over. I wrote that down wrong. I'm going to divide by 4. If you divided by 2, you would get 2/4, and then you could divide by 2 to get the 1/2. So I was kind of doing both in my head there. But your smallest fraction mixed number is 7 1/2. So let's look at these 2. 5 can go into 18 3 whole times. That's 15, so then we have 3 left over out of 5, and this is as far as I can go. 13 here can go in there 3 times. Okay, I know this was a big denominator, so you might have had to add 13 a bunch of times to see how close you could get. 3 times gives us 39, so then we have just 1 left over. So that's our final answer there. All right, mixed number to improper. So we're just going the opposite way. So to do this, we are going to break this whole number back up. So remember, a whole number represents, our denominator is basically full. So 4/4, that's 1 whole. So I've got 2 of those, which means actually I've got 8. So what we actually do, the shortcut, is to multiply your whole number and your denominator. And then we've got our individual numerators to add in. So that gives us 11/4, and our denominator stays the same. So multiply 6 and 7 gives me 42. 42 plus 4 gives me 46/7. All right, so pause and try the next 4. So 4 times 5 gives us 20, plus 2 gives us 22/5. 8 times 3 is 24, plus 2 gives us 26/3. That denominator just stays the same. Okay, 3 times 9 is 27. 27 plus 5 gives me 32, keeping the denominator a 9. 1 times 11 is still 11, plus 8 gives us 19/11. Good. So this way is a little faster because you're going to an improper form, so there's no reducing or simplifying there. So equivalent fractions, we've actually kind of, like, these are equivalent fractions. They're just in different forms. So we're going to do some more examples of equivalent fractions down here. So an equivalent fraction has the same value. They're equal in value. Okay, so that's kind of the root word for equivalent, is equal. So there are many equivalent fractions. Like, I could list a ton of fractions here and I wouldn't even come close to all of the equivalent fractions there are. So how do I come up with just one? As long as you are multiplying or dividing the numerator and denominator by the same number, you're going to get an equivalent fraction. So for example, if I multiply both the top and bottom by 2, we get 6/8. That's an equivalent fraction. And I'm not changing the value because I'm not multiplying this fraction by 2. I'm multiplying it by 2/2, which is actually 1. I'm multiplying by 1 in the form of 2/2. Okay, so I could choose another one. Maybe instead of 2, I'm going to multiply by 6. Okay, so 3 times 6 would give me 18. 4 times 6 would give me 24. So that's an equivalent fraction. Okay, 6 times, I'm just going to pick, let's go 10. 10's an easy one. Now remember, I'm not multiplying by 10, I'm actually multiplying by 1 in the form of 10/10. Okay, so this gives me 60/70, which is an equivalent fraction. We could do 2 here also. So 6 times 2 gives me 12. 7 times 2 gives me 14. That is an equivalent fraction. So go ahead and pause the video and see if you can write down 2 equivalent fractions for each of the fractions I have given you. All right, so you could have many different fractions. I'm just going to write down a couple. Okay, just because you didn't have these doesn't mean they are, the ones you have are not correct. So here are just some examples. of ones you could have. Okay. So a possible question I could ask you on a quiz or a test is kind of listed right here. So circle the fraction that is not equivalent to 4/5. So that means all of these fractions are equivalent to 4/5 except for one. Okay, so you need to find the one that is not equivalent. So I'm actually going to have you try this first and then play through to see if you got it right. So there's a couple different ways to think through this problem. First of all, I'll just go with this is the fraction that is not equivalent. So how I like to think about it is I like to kind of reduce all of my fractions, which means here I'm thinking about dividing. So I know I can divide these both by 8 and then I get 4/5. Okay, I know I can divide these both by 10 and I'm going to get 4/5. I'm going to divide these both by 2 and I'm going to get 4/5. Okay, I can then divide these both by 9 and I'm going to get 4/5. Okay, so here, if I can't divide by 4, when I see 16, I think about dividing by 4. Well, 25 can't be divided by 4. 25, I think about dividing by 5. 16 can't be divided by 5. They're not both even. I can't divide by 2. So I can't think of a way where I could get to 4/5. Okay, so this is the non-equivalent fraction. All right, 2 more boxes. So simplifying fractions. So simplifying or reduce mean similar things. So basically we're going to take these fractions and bring it to lowest terms. That's another thing you might see on a test or have heard other teachers say. So this one is not improper, so I don't need to make it into a mixed number, but I can reduce it. So what can I divide 18 and 21 by? Okay, I think of 3. So then I get 6 and 7. And then you always want to check, can I reduce this again? Because sometimes we might not choose a big enough number here. But in this case, 6/7 is as low as we can go. So there's always more than one pass. So like this next one we're going to do, I'm kind of going to do this one twice. I think right away about dividing by 6. So 54 divided by 6 gives me 9. 60 divided by 6 gives me 10. And I'm at my lowest term. But maybe you couldn't think of 6. Maybe you're like, they're both even, I'm going to divide by 2. Which 2 is often a great way to start if you're like, I don't even know what number. If they're both even, 2 is a great one to start. So 54 divided by 2, you know, some of you might not know this in your head, so you might want to come to the side. 2 can go into 5 twice. And then, so I subtracted 4 and got 1, brought down my 4. 2 can go into 14 7 times. So that brings me to 27. 60 divided by 2 is 30. This is still not in its lowest term. So now I can do 3 to bring me to my 9/10. Okay? So it doesn't matter how I get there, whether I did it in one step or a couple steps, as long as we get to those lowest terms is all we want to do. So go ahead and pause that video and give these a try. So here, this one is improper. So first I chose to make it a mixed number. Then I'm choosing to reduce. Okay, you don't have to do it in this order. You could reduce and then make a mixed number. But either way, you should end up at 5 1/2. Okay, here I'm going to divide by 9, which gives me 2/5. That's your lowest term. And here I went straight to 16, which gives me 2/1, which is just 2. So this last one's kind of tricky. All right, comparing fractions. To compare fractions, we must have a common denominator. Okay, and common denominators are going to help us in our next fraction lesson also. Okay, so they're not going away. We need to know how to get a common denominator. So, if I'm going to compare the fractions 2/3 and 5/9, I need to think of what is a good common denominator for 3 and 9. Okay, and there's always more than one. So I think 9, because I can make 3 and 9. Okay, but maybe you were thinking 27 because you like to multiply these. Either one would work. So if I choose 9, though, I don't have to change this fraction because I've already got a denominator of 9. So I have to change this fraction, and I need to make an equivalent fraction. So I'm timesing 3 by 3 here, which means I have to times 2 by 3 to get 6. So now I'm not looking at this fraction anymore because I've made an equivalent fraction. So this is kind of replacing this one. Now that I have common denominators, I can compare them. Okay, so this is our less than symbol. If you get them mixed up, this is our more than symbol, and then we have our equal to symbol. Okay, so we want to say here that 6 is more than or greater than 5/9. Okay, now that we kind of have the same denominator, we can compare those. So another example, with 4 and 6, I can't make 4 into a 6 or 6 into a 4, so I can't use one of these denominators. I need to actually rewrite this whole problem by making 2 different equivalent fractions for both of them. So, common denominator for 4 and 6. Okay, 12 is a good one, 24 is a good one. There's more than one. So I'm going to use 12 because it's lower. I like to use my lowest one, which means this first fraction here, to get to 12, I'm multiplying by 3. So I have to multiply the top here by 3 to get 9. So those two are my equivalent fractions. All right, and then 6 to 12, I'm multiplying by 2. So I'm going to do the same thing to the top to get 10. So now I can compare those. 9 is less than 10, so 9/12 is less than 10/12. All right, so I am going to have you try a couple of these, so I'm going to write them in. So go ahead and give each of those a try. Okay, so I only changed the second fraction here. So then I found out that 4 is greater than 3, or more than 3. Okay, and here I changed both of them. I used 21. So I'm multiplying by 3 here. I'm multiplying by 7 here. And then 7 is less than 9.